Today we're working on topic 48, regression equations. We're going to create curves of best fit and by finding their equations, and then use them to help us solve practical problems involving plugging in an x to determine a y value. When taking data and graphing it as a scatter plot, it helps us see a pattern. From that pattern, we're able to get an algebraic equation, which we call the curve of best fit. For this course, we're going to deal with three curves of best fit: linear, quadratic, which we covered in this video, and exponential, which we covered at a later time. With our equation in hand, we can use this to make predictions about other data values, and all of this will be done with Desmos graphing calculator. So the process is fairly straightforward. There are 4 steps in terms of data entry, and then 3 steps in terms of creating the equation and using it to help us predict. So the first part, data entry. We're going to start off in Desmos by clicking the plus symbol. Then we're going to choose table. From there, we're going to go ahead and enter our data table in to the X1 and Y1 categories. And then we're going to click on zoom fit in order to view the data as a graph, zooming in on Desmos. From there, we're now entering the equation portion of the process. In order to get the regression equation, we need to type in a specific code that tells Desmos, hey, find me this regression equation. For a linear function, this is the exact code that we will type in. For a quadratic, this is the exact code we are going to type in. Zooming in on this, you'll notice that it is just y sub 1 with a little tilde, not an equal sign, mx1 plus b. And then for quadratic, y sub 1 tilde, ax1 squared plus bx1 plus c. When we do this, it will spit out values that correspond to m and b, the parameters. And for quadratic, it'll spit out values for a, b, and c, the parameters down below. It is our job to go ahead then and to write in the equation in a line below it. Of course, we have to type, when we type this equation, we want to go ahead and round to the indicated place value. Sometimes the problem will ask you to round to the tenths, the hundredths, or the thousandths. That is our job to go ahead and truncate the values that are given to us by Desmos into our equation. From there, we can simply just copy and paste this equation over and substitute in any x value we're looking to find. So for instance, if I was using this linear equation and I wanted to know when x is equal to 10, what is the y value? I simply took x is equal to 10 and substituted it in for x in my equation, got an answer, and of course, rounding to the indicated value that is necessary. All right, now that we've gone over the general process, let's look at 2 examples. We'll do a linear and a quadratic regression, showing you exactly how this works. I'll walk through the linear, and then give you the opportunity to try the quadratic on your own before revealing the answer. So linear regression. In this particular problem, a number of newly reported crime cases in New York is shown in the table below, where X represents the number of years since 2004. So on this particular case, I like to go ahead and write in the year next to it. 2004, 2005, that's 1 year after, 2006, 2007, and 2008, just as future reference, because in our problem, if we're looking at the very last sentence, using this equation, predict the number of cases in 2014. So notice we are going to need to find the number of cases in 2014. That is the x value we will substitute in and figure out our y value. So 2014, of course, is 10 years after 2004. So how are we going to go ahead and get our equation? Well, we're going to go back, and first thing we need to do is click the plus symbol, create a table, enter our data, and zoom fit. So let's go ahead and do that. You're going to click the plus symbol to add an item, clicking on table. You can change the color if you'd like. I'll change it to red. We are now going to simply enter in our data as listed in the table. I like to enter in all the x's first. 0, enter 1, 2, 3, and 4. Sometimes Desmos picks up on the pattern. And then we can enter all the corresponding y values as such. Making sure before we go on that we actually typed in our values correctly. We are good to go. Now we will click the zoom fit feature of the graph. This will go ahead and zoom in on the data points, which we see here. Brilliant. Now, this problem is asking for a linear regression. So that is our code to go ahead and use this code into Desmos to get the values of our parameters and therefore our equations. So we are going to go ahead and type in y1. Now to get the subscript, you just need to type the number 1 and it'll automatically subscript for you. Shift is above, the tilde is right next to the 1. mx1 plus b. And just like that, Desmos will automatically go ahead and give us the equation as the parameters that are listed there. Now, in our particular problem, it had asked us to round the coefficients to the nearest hundredth, which is the 2 decimal places. And it looks like we don't really need to worry about that because we're going to go out to the 1 decimal place. So again, clarifying and making sure we're rounding to the location. So I'm simply going to recopy these parameter values over. 422.4.2 m x plus 947.6. We're typing in the m value for m in the equation. We're typing in the b value, positive or negative, for there. And you notice that right there, I can change my colors here, our data looks pretty similar to the data in the graph. All right, last thing I need to do is I'm going to go ahead and solve for some unknown x value. We had said we want to figure out when we are 10 years away. So we're going to simply substitute in 10. And we get 1,369.6. So writing down the equation, what we substituted in and getting our answer, we finally have to go ahead and round to the nearest whole number. So the 0.6 rounds up, so we have 1,370 new cases. And that's all there is to it. So moving on to the quadratic regression, I'm going to let you try this on your own. However, if we go back to the Desmos table, I'll show you a little pro tip right here. I'm simply going to delete all the work I've done so far. And I'm not, instead of creating a new table, I'm just going to go ahead and backspace all of the x values, and that will delete the corresponding y values for me, except the very first one. And now we're able to go ahead and reuse this table over again, this time typing in our quadratic values. So why don't you take a moment and see if you can figure out the quadratic regression equation using this code, along with using to predict the sales price of $23.5. What would the profit be? I'll reveal the answer in 3, 2, 1. Having typed our data into Desmos and using the code to get the parameters, we see our equation goes through the majority of the data. Now the problem calls for us to go ahead and round all of our coefficients to the nearest 10th. So that means we'll round everything to the first decimal place, which gives us the regression equation negative 1x squared plus 73.7x minus 574.3. Now notice our regression equation here is slightly off from the original trend line, and that's just due to rounding. We rounded, this had 5 values after the decimal place, and we rounded it to none, no decimal. All right. So a rounding causes us to have a little bit of a trend change, but that's okay. That's what the problem asked us to use. So now we're able to go ahead and use this to help us predict. Now in our problem, we wanted to predict what happens when we sell for $23.5, $23.50. So we plug in 23.50 into x from our trend equation, and that'll give us a value. We're going to go ahead and round our answer to the nearest dollar. So taking this portion of the equation, pasting it over, and then substituting in with parentheses, we should get $605.40, which rounding to the nearest dollar gives us $605 for our profit. Key things to remember: follow the steps on the first page, making sure to delete all the x and y values in the original table. It just makes things easier. And then using our code that's listed there and type it in the parameters with the correct rounding as indicated in the problem, along with rounding in the final answer. Topic 48.